Hello everyone. So it's been a long. I have created the video due to some, lot many stuffs I have going on. Okay, so today I wanted to discuss two things. Okay, we will discuss cycle detection first in undirected graph and then in directed graph. Now for undirected graph, there are two methods. I'll go through DFS. BFS you can do by yourself because the coding and logic remains same, and only you have to use the queue instead of the recursive stack. So thus you can do by yourself. Cool. And directed graph we will see later in this video itself. Okay. Now you know what a cycle, right? So you have, let's say, this one, two, three, four, and the five, six, seven. Okay, so let's say this is your graph with two components. Okay, you'll first start with one, one, two, three, four. Again, you reached one. That means this is the cycle. Okay, same way 5, 6, 7. You are not reaching anywhere. This is not cycle, but fully a graph is yes, a cycle. So what we will do for the DFS? For the DFS, we know that we are putting visited array. Okay, and if it's not visited, if our child is not visited, then only we are doing the DFS in that. Now let's say your child is not visited. So let's say 1, you go to 2, you mark, I'll mark the visited as greens, okay? So this is visited, this is visited, this is visited. Then you come to 4, this is visited. Now from 4, where you will go? You'll go to 1. Okay, but this is already visited. This is already visited. Now, ideally, our logic says that if it is not cycle, 4 should be only connected to one edge, which is 3. Okay, so at this time, this one should be 3. If it's not 3, that means if it's something else, then you have cycle, of course. So what we will do? We will maintain a parent for each node. So I have a parent of -1 to my starting node. Then I have parent 2 for 2 it's 1, for 3 it's 2, for 4 it's 3. Now when I'm coming here for 1, okay, for 1, at that time my parent will be 4 for my 1. It will say that the parent is 4 for this visiting node 1. Okay, but for 4 you went to 1, and your parent it should be 4, but it's not matching. It's already -1. Your parent is already -1 for this 1. It couldn't be 4. It should not be 4. That means you will return cycle as true. Okay, so let's say you have a bull DFS function, which is cycle detection. You have a node, you have adjacency list, you have visited, and you also have a parent. Now, initially, what you'll do, you'll make the visited of node as 1, of course, and this parent is -1 here. Now, what you'll do, for auto implicit element in adjacency of this node, that means you're going to the child of this node. Okay, so now this node is parent for this element, for this element, and its grandparent is this parent, if I'm not wrong, right? Okay, so if not visited of this element, that means you have never visited this child element, then it's okay. What you will do, if you find a cycle from this child also, okay, you will call a recursion. If you will find from this child also, now the parent will become node. Okay, for this element parent, its parent will be node. So if you will find a cycle out of there, you will return true or 1, let's say. Else if, okay, now this if is closed. Else if you have your visited of element as 1. So take an example, your element is now 1. In our example, this element is 1, which is coming from this node as 4. So your node is 4. Okay, and that time your parent was 3, because when you reached node, at that time this parent will be the parent of this node, which is 3. Okay, okay, so else if your parent is not equal to element, that means 3 is not equal to 1, because 4 can be parent of 3 only. It has come from 4. It is From 3 4 came. Okay, so vice versa, 4 should be a parent of 3 only. If 4 is a parent of 1 also, and 1 is already visited, let's say 4 is going to 5, that is still okay because 5 is not visited. For not visited elements, 4 can be parent. For visited elements, it can be parent only if it has came from them. Only if it has came from them. Okay? Mark my words. Then what you will do, you will return 1. That means there is a cycle. Otherwise, false for sure. Okay? Let's code it. I hope you got this. You have to do the same coding when you do for the BFS also. Okay. So we'll create adjacency list, vector of int adjacency for int I0, I less than edges dot size, I plus plus, adjacency of edges I0 dot pushback I1. Cool. Okay, we will maintain a visited array also. Okay. Now, you'll go to each of this nodes. If it's not visited, you will call eCycle DFS starting from this node I, adjacency list, visited, and parent we will set here as -1 because we're starting. If this is the case, you will return true if it's cycle. Okay. If from no node we got it's a cycle, it will return 1 for false. Sorry. Okay. Now we have a cycle DFS, which have this node, which is current node, vector of int adjacency, vector of int ampersand visited, and int parent. Now we will mark this node as visited for sure, and we will go to its child element. Now if the child is not visited, then this node can be a parent of child. Node can be a parent of element. Okay, but if we get the cycle from there, so if is cycle DFS, if we'll get a cycle out of there with element, your adjacency, your visited, and your node, then what we will do, we will return true. Sorry. Okay. Else if you've got visited as your child, okay, then it should be your parent only. So else if your element is not equal to parent, we will return true. That means you got a cycle. Otherwise, it will be false. Cool. I hope you got this. Okay, same you have to do for BFS. Do for the same question with the BFS approach. Fine. Now let's move to a directed graph approach. Okay. So now we will move to second directed graph. Now for BFS approach, there is another algorithm in itself which is called as topological sort algorithm, which I'll cover in a separate video later. But today we will see the DFS algorithm for this. Now, keeping only parent wouldn't suffice. Okay. Now let's say you have this thing. 1 is connected to 2, 0, 2. Is this a cycle or not? So if I go via parent, let's say 1 is the parent of 0. So if I have moved in this direction, okay, and then 0 is the parent of 2. So then I have moved into this direction. Now for 2, I cannot go to 1. 2 is not connected to 1. Okay, so here there is no cycle. I cannot go in this direction. And if at all you maintain a parent thing, then let's say 2 is connected to maybe 3. Okay, it is going in this direction. But let's say 1 is connected to 2, 2 is and 2 is connected to 0, and 0 is connected to 1. If this is the case, okay, let me mark it with yellow color. If this is the case, then 1 is connected to 2, 2 is connected to 0, 0 is connected to 1. So that is a cycle. Now, keeping only parent wouldn't suffice this, because in this root only you have to found whether this element is the parent of this or not. If the root changes, let's say if this root becomes, then 2 is the parent of 3. Here 2 is not the parent of 0. But for this root, 2 is the parent of 0 and 0 is the parent of 1. But if I change the root, the parent changes. Like for 3, it's 2. Okay. So according to root, you have to maintain parent over here. So what we will do? We will have two arrays. One is called visited, another is called DFS visited. Now this DFS visited, what it does is, in one DFS cycle, it will mark all nodes. It will mark all visited nodes. Okay. So let's say we have this case. Okay. Now you have visited of node and DFS visited also. Okay. Now for this directed graph, my visited, let's say I start from 1. So visited of 1 is 1. Then I'll go to 2. Okay. And I'll make the DFS visited 1 also 1. So I'm taking one path. I'm going in deep level, one path. Now when I'll return, I'll put this DFS, I'll drop this DFS visited of I as 0, 0, 0. So that means for different path, I have different nodes, and that can also form a cycle. Okay. I hope you're getting my point. Okay. Now we have visited of I and DFS visited I. We put it both one. Now we are going to 2. Okay. So for going to 2, 2 is not visited. So we'll make the visited of 2 as 1. Okay, so we'll do the DFS for the 2, ideally. Basically, we'll do the DFS of 2. It will make visited of 2 as 1 and DFS visited of 2 as also 1. Now we'll go to 0. So it will do for the 0 also same. Okay, for visited and for DFS visited also. Now with the 0, you'll go to 1. So you will go to 1 only if, now 1 is not visited. If not visited, then only we are going. Else, if it is already DFS visited. Now, what does this DFS visited means? That 1 in this cycle only has come in a correct path, okay, and it became DFS visited also. That means it's in this route only, in my this current cycle only. That's why its DFS visited is 1. So that means there is a cycle. So I'll return true out of here. I'll return true out of here. Okay, I hope you got. Okay, now consider this scenario: 1 to 2, 2 to 3, 3 to 4, and then you have 3 to 6 also. 6 to, sorry, 7, 7 to 1. So that is the spec cycle. Now with 1, DFS visited, both will be 1. It will go to 2. It will go to 3. Now 3 will go to 4. Okay. So until this, your DFS visited 1, DFS visited, DFS visited, DFS visited. Now with the 4, you have nothing to go with. Okay. So what you'll do? You'll make its DFS visited 0. Then this 0. Now with 3, you have now the 6. So you make DFS visited of 4 only 0. You didn't make DFS visited of 3 yet 0. You'll make it 0 only if you have no path available. Then you will make the DFS visited 0 out of here. Okay. Now with the 3, you have already still have. This 1 to already have. With 6, yes. 7, yes. 1, now I got yes here. So that means in this path, I have 1 and I got the cycle. So I'll return true. I hope you got. Okay. Let's solve it and you'll get a better idea. Cool. Okay. So we have directed graph cycle now. The same thing. So I'll just push from edges of I0 to I1 only. Okay. So we have vector of int adjacency list of V. adjacency of edges I 0 only will push back to I1. Cool? Fine. Now we have a visited array. So we'll have two arrays. Vector of int visited of size v and vector of int DFS visited. That's for one root in DFS internally. Okay. DFS visited v0. For int I0, I less than v, I plus plus. If not visited of I, then if is cycle, we have this I, we have adjacency, we have visited and DFS visited will return true. It will return false here. Now you have pull is cycle int node. You have vector of int adjacency. You have vector of int visited and DFS visited also. Okay. Now what you do? You will initially make visited of node as 1 and DFS visited of node as also 1. Because in undirected it's two ways. So you can say that if it has come from this parent, the next should be its parent only. Then only it can come. Okay. But here you cannot say that because it's only one way. Edge is only one way. Okay. Now what you can do for auto ampersand element in adjacency of this node. If okay, for auto ampersand element in adjacency of node, if not visited of element, of course, you have to do the BFS. So if is cycle, you will get the cycle out from this element. It's good only. Okay, it's not good. We have to return true over here. Now, else if it's already visited and it's DFS visited also. Else if DFS visited, what? Your element. Okay, that means it's a cycle. Now, for sure. Now, after coming out of this for loop, you have visited all the child nodes of this current node. So, you have got into the deeper. Now, you will start a different route in itself. So, for this DFS visited node, you will mark it as 0. So, it's like a backtracking. Okay. You will mark it as 0 so that in the next path, it could become 1 again. Otherwise, it would create a problem if you'll mark it as 1 only. Hmm? Okay. And we will return false if we haven't got any cycles. Cool. I hope you got. BFS approach we'll discuss in the next video. Okay. In the next video, I will mostly cover topological sort or else shortest distance for